Hey guys, this is Coach Lowe and geometry, and we are going to talk today about trapezoids and kites. So this is 6-6, trapezoids and kites. All right, so hopefully you have a water or Gatorade or something, maybe a little snack, because this video may be a little bit lengthy, and I know you guys like it when the videos are about 16 or 17 minutes long, so that's what I'm shooting for. All right, so at the beginning of chapter 6 notes, I had you guys put some green windows, and this is the last set of windows that we're going to write info on. So the last set was trapezoids and kites. So let's open that up and go ahead and take some notes. Trapezoids are quadrilateral with exactly one pair of parallel sides. All right, so we know it's a quadrilateral, exactly one pair of parallel sides. All right, the parallel sides are called the base. So on the front of your picture, or on the front of your window where your picture is, if you would like to draw this, I'll go ahead and have a little picture up here. See if I can get these sides to be parallel to each other. All right, so I'll go ahead and mark these. These are my parallel sides. So the parallel sides are called the base. I know you want to sing a song, don't you? And these are called the legs. So base. We'll call this trapezoid ABCD. All right, so the non-parallel sides, so these outsides, the non-parallel sides are called the legs. By the way, the base, they do not have to be top and bottom. These sides over here could be parallel to each other. Those would be the base. Top and bottom would be the leg. So it doesn't matter which way it's facing. Base angles are here next to each other. So AD would be base angles, and then BC would be base angles. So there's your pairs of base angles. So B and C, and then A and D. All right, so let's talk about special types of trapezoids. An isosceles trapezoid the legs are congruent to each other. So in an isosceles trapezoid, the legs are congruent to each other. Also, each pair of base angles are congruent. All right. So if you see legs of a trapezoid marked like this, that they are congruent, then we're dealing with an isosceles trapezoid. Then we also know that the base angles are congruent. So A and D would be congruent to each other, and then B and C would be congruent to each other. So if you need to draw an extra picture down here, if you have room, you need to draw this picture down here, probably be a good idea so that you can keep that straight. All right, so theorems, if you would like to go back to where we left off from 6-5, so you can go away from the green part. So let's go ahead and write down 6-5 trapezoids and kites. All right, so we know trapezoid. Now, if you want to write this again, please do. You can pause the video. You can write this stuff that we wrote. Just write it again. It will help you remember it. But go ahead and pause the video. But theorem 6.21, which means this is the 21st theorem that we've written down. Isn't that crazy? So chapter 6, 21st theorem that we've written down. If a trapezoid is isosceles, then each pair of base angles is congruent. So that looks like this little trapezoid here. So if a trapezoid is isosceles, which means the legs are congruent to each other, then the base angles are congruent. So A is congruent to B, D is congruent to C. All right, and these would be marked parallel as well. All right, 6.22. If a trapezoid has one pair of congruent base angles, then the isosceles is a trapezoid. Now that's almost the converse of what we wrote here, but this just says it has to have one pair of congruent base angles. Why would that be true? Oops, then it's an isosceles trapezoid. So why would that be true if we have a figure here and let's do parallel sides on the. So here's my trapezoid. Here are the legs. And these are congruent. So why would we be able to say that this is isosceles if these two are congruent? Well, we know that that forces these two to be congruent as well, because we have 360 degrees in a triangle. We take those out. These legs are congruent to each other, forces those as well to be congruent. All right, so have an isosceles trapezoid again. All right, then 6.23 or 6.23. A trapezoid is isosceles if and only if the diagonals are congruent. All right, so if and only if means it works both directions. So if I have a trapezoid and the diagonals are congruent, then I know it's isosceles. If a trapezoid is isosceles, then the diagonals are congruent. That's the if and only if. It means the converse is true as well. All right, let me go ahead and draw this here. Parallel, congruent, diagonals are congruent. All right. A lot of stuff about isosceles or about trapezoids. Okay, let me give you an example and we'll see if you can handle it. I know you can. All right, so here's number one. Go ahead and draw this trapezoid with me. And this is trapezoid QRST. And there are the bases. They are parallel to each other. QT is 14, RS is 14. Could you please find the measure of angle S for me? Oh, and angle Q is 63 degrees. Could you please find the measure of angle S? Go ahead and pause the video and try it from what you know. All right, now that you're back, we talked just back here a little ways that if a trapezoid is isosceles, then the pair of base angles is congruent. Each pair of base angles is congruent. And we talked before that if we have legs of this trapezoid that are congruent, it makes it isosceles. So I know to start with that this is an isosceles trapezoid. All right, so now that I know it's an isosceles trapezoid, base, legs, congruent, angles, this is 63. These two must be congruent. Now here's the cool thing. We know that in a quadrilateral there are 360 degrees. So I can take 360 and subtract these two angles from it. 63 times 2 is 126. So I'll subtract those, and that leaves me with 234. And then I need to split those evenly between those two. So 234 divided by 2 is 117 degrees. So I know the measure of angle T is 117 degrees, and also the measure of angle S is 117 degrees. All right, hopefully that makes lots of sense. I'll let you try one more. All right, could you please find the measure of angle M? The measure of angle M. Go ahead and pause the video and try it out. Okay, now that you're back again, we have a nice isosceles triangle. The legs are congruent to each other. So that means these angles are congruent, and M and L are congruent to each other. So same process that we did for number 1. Add these two guys together and subtract them from 360. And that leaves me with 76 degrees. And I'm going to split that in half. I'm going to divide that by 2 so that we can get each of these. And that's 38 degrees. 76 divided by 2 is 38. All right. Let's move on to trapezoids and the mid-segment theorem. So this is 6.24 or 624. All right, trapezoid mid-segment theorem. Go ahead and draw a big old trapezoid here. All right. So trapezoid mid-segment theorem says if I find the midpoints of the legs and I connect them, that's a mid-segment. Oops, lost it there. So mid-segment of a trapezoid is a segment that connects the midpoints of the legs. Midpoints of legs. All right. It's also parallel to the bases. Okay, so here's a cool thing. These are all parallel to each other, so let me just go ahead and write down some letters here. How about A, B, C, D, E, F. AF is parallel to BE, BE is parallel to CD, AF is parallel to CD, all that good stuff. We can write those forever. All right, but the mid-segment theorem says that the length of BE, the length of the mid-segment, is half of the sum of the bases. So if I add AF together and CD together and then cut that in half, that gives me the length of BE. Now, hopefully that makes sense to you. This is halfway between here. And so I'm adding these two together and dividing by 2 to get the mid segment, the length of the mid segment. All right, so let me give you a problem that goes with that. All right, so this is H, J, S, oops, let's go K there, K, and L. And then the mid segment is going to be TS. So midpoint between H, or midpoint for HL, midpoint for JK, and we connect those. So T is the midpoint of HL, S is the midpoint of JK, and they are connected. This is parallel to that. We know these segments are congruent to each other, and then JS is congruent to SK because S is the midpoint and T is the midpoint over here. All right. If HJ is 14 and LK is 42, what is TS? Well, we know that TS is the midsegment, and we know that TS is equal to HJ plus LK divided by 2, if you want to think about it that way. So if I can just add HJ plus LK and then divide that by 2, we've got the midsegment. All right, so HJ is 14, LJ is 42. So 14 plus 42 divided by 2, or half of that. 14 and 42 is 56. Divided by 2 is 28. So the length of this is 28. Now look at my lengths. Makes sense. We're good to go. All right, so if I add 14 here, I get 28. I add 14 here, I get 42. All right, let's keep going. The last thing I want to I'm already at 16 minutes. Woo! Going to be sassy to me tomorrow. Last thing I want to talk to you about are kites. All right, so 6.25. If a quadrilateral is a kite, then its diagonals are perpendicular. So you can put this on the green part if you want to. Probably need to write that in the green. Just put kite, then put diagonals are perpendicular. And then add this one also. If a quadrilateral is a kite, then exactly one pair of opposite angles is congruent, are congruent. Exactly, that would be is, right? Exactly one pair of opposite angles is congruent. So go ahead and add those on the green part. So you can just write kite and then 2 bullets. Diagonals are congruent. Exactly one pair of opposite angles is congruent. All right, so let's go ahead and look at how we would use that. So let's draw a couple of kites here. We'll work a couple of problems. And then I have one more thing to tell you, and then I promise I'll be finished. So we're probably going to be pushing about 20 on this one. Sorry. Got to get all the info to you, though. Better than doing an hour of homework, right? Right? Okay. All right, so here's a kite. I want to find the measure of angle D. This is 36 degrees. These are congruent. These two are congruent. And this is 70. All right, now, Theorem 25 says, if a quadrilateral, Theorem 26 says, exactly one pair of opposite angles is congruent. All right, so C and A are opposite angles. Are they congruent? No, they're not. Okay, so that means B and D must be congruent. This is a kite, so it must be congruent. All right, so let's go ahead and figure out how in the world are, by the way, let me go ahead and tell you about a kite. A kite, the reason why I know this is a kite is because it has 2 pairs of consecutive sides congruent. So make sure you put that on the kite, on the green part. If you see 2 pairs of consecutive sides that are congruent, it's a kite. So right next to each other, BC, CD, consecutive sides congruent. AD or DA, AB, consecutive sides congruent. So I know this is a kite to start with. When I'm looking at it, it's a kite. All right, so I know these opposite angles must be congruent. Well, we know this is a quadrilateral, so 360 degrees, I can subtract these 2 guys out of it and then divide what's left by 2 because I have to split it evenly between. So 36 plus 70 is 106, and I'll subtract that out, and that leaves me with 254. And then 254 divided by 2 is 127. So each of these angles is 127 degrees. All right, now let's get one for 625. All right, so let's draw another kite over here. And I'll tell you again, or maybe you can tell me how you know this is a kite. This is H, R, S, and E. And I'll go ahead and mark these. So how would I know this is a kite? Exactly. Consecutive sides are congruent. All right, now I'm dealing with diagonals. All right, so I know that diagonals are perpendicular, which means these are right angles. So I have 4 right angles. Diagonals are perpendicular. This is 20, and this is 12, and this is 12. And I need to find RH. Well, RH is here, and I see that I have a right triangle, a leg of 20, a leg of 12, and I'm missing the hypotenuse. So I will use Pythagorean theorem. C squared equals 20 squared plus 12 squared. So C squared equals 400 plus 144, or C squared is 544. So C is the square root of 544. Now I simplified that because you can break 544 down, and I took out a 4, which made it, if I divide this by 4, it makes it 136, and I took out another 4, which makes it 136 divided by 4 is 34. So these two can come out. That's a perfect square, so that makes it 4 times the square root of 34, or approximately 23.3. All right, next year in Algebra 2, you'll have to do this little breakdown. So good idea to kind of go ahead and get in the habit of doing that. All right, last thing I want to tell you, and we're going to work one like this in class, but if you have to verify that a shape is a trapezoid, we like to verify, remember? When I want to verify that it's a trapezoid, I'm going to show one pair of opposite sides are parallel. Now think about this. If I want to show opposite sides are parallel, I need slope. All right, so you would graph it, you would find the opposite sides, look at their slopes. If I want to determine if it's an isosceles trapezoid, then after I've determined that opposite sides are parallel to each other, then the other sides that remember are called legs. I want to show that the legs are congruent, which means I need the length, which tells me distance formula. So we will work something like this in class. Make sure that you have these notes so that we can do that. And then in the bottom left corner, I want you to put a P for prior and show that to me when you show me your notes. All right, guys, this is Coach Lowe, and I'm out.